populated area. Here's a colorized image of what it looks like, and unfortunately, Jersey City's right in the center of the worst light pollution around. So if you want to look at the nighttime sky in this particular area, it's going to be very, very difficult. Now, I actually live about 80 miles northwest of here, up in Orange County, New York. And I'm right on the border between orange and yellow in this photograph. I can see the Milky Way. Okay, I can see the band of stars, which is the disk of our galaxy. At the top of the sky. But as I get to the horizon, there's quite a bit of glow, quite a bit of what we call light domes due to different places. Now, really, from here, from Jersey City, there aren't a lot of places you can travel to where the light pollution becomes, fairly minimal. Up here in the Catskills, there's some, fairly good viewing skies. Out here in north central Pennsylvania, and then finally up in the Adirondacks, there's actually a very nice place to view right here. But for us in the Northeast, seeing a dark sky is something that is unfortunately, difficult to do without traveling a great distance. Of course, up in Maine, we've got beautiful dark skies up here because really there's very little population up there. You want to go to the best viewing skies in the world, you've got to go to some place where, first of all, there aren't a lot of sources of light pollution. High altitude is better because you've got less atmosphere between you and the sky. And a drier atmosphere is also much better because with fewer water vapor particles, there's less possibilities of having aerosols condense and therefore scatter light. There's a place called the Atacama Desert. I don't know if you've ever heard of this. It's actually in South America. And the Andes Mountains essentially block prevailing winds. And there's something called orographic lifting. If we take warm, moist air and we raise its altitude, it expands, cools down, the water vapor precipitates out, and the Atacama Desert is actually in the rain shadow of the Andes Mountains, and therefore the air is extremely dry. It's at a very good altitude, and not much lives out there, so not much light pollution. And it's really the location of some of our best observatories in the world. So the Atacama Desert, if you wanted to look for really good viewing skies, this would be the place to go. Mauna Kea, Hawaii, is also another location of very good viewing. Mauna Kea is the tallest mountain. It's a volcano in Hawaii. And it's a very special type of volcano, in fact. It's a shield volcano. And this allows the air to very gradually climb in altitude. So there's not much turbulence associated with this particular location. And again, we have some of the best observatories in the world located at this peak. Now, Mauna Kea has actually experienced a little bit of controversy. The native Hawaiians view this mountain as being very sacred to their ancestry and to their religion. And although originally we did build a few observatories out there, the native Hawaiians are really getting upset by the proliferation of all these different observatories, and they try to put a stop to the building of the new 30-meter telescope. And we'll see if they're successful in stopping this. But Mauna Kea, the Canary Islands are another place of very good observing. In fact, the Canary Islands, Mauna Kea, and the Atacama Desert are the location of the 3 locations of the largest telescopes in the world. There's one more location, believe it or not, down in Antarctica. there are different locations called Dome A, Dome C. These are on giant ice sheets, and these are also thought to have some of the best viewing in the world. Because like the Atacama Desert, there's not much humidity in the air. When you get to these ultra cold temperatures, we get to a point where, and they're high in altitude because the ice sheet is so tall, we get to the point where there's very little to scatter the light. So, you want to see the perfect viewing conditions. You want to see, certainly the moon is a wonderful thing to look at, either with the naked eye or with binoculars or even with a telescope. But if you want to see other things in the nighttime sky, which are not very bright, you want to go beyond just looking at the moon and the planets. You want to look at stars, maybe star clusters, maybe nebula. You want a moonless night. You want to choose a night where the moon rises late. Usually, once we get past the full moon into the later phases during, you can avoid the moon for a good part of the night. You want low levels of aerosol pollution, even though they're not a major contributor that enhances light pollution. The further you can get away from these aerosols, the better the viewing conditions can be. Low levels of light pollution. Get away from populations. People are not very conducive, or I should say, populations are not very conducive for good viewing conditions. Low levels of turbulence. When you're looking at objects through a telescope, you magnify everything, not only including the object you're looking at, but also the turbulence in the atmosphere. Why do stars twinkle? They twinkle because there's a turbulence layer, up in the atmosphere, up toward the top of the troposphere, where the wind, I don't understand the complete meteorological phenomena, but basically the wind changes speed, and this causes the stars to twinkle. If we look through a telescope, we can clearly see that this turbulence alters different images of objects. High altitude is better. Why? You're getting closer to space. There's less atmosphere between you and space. Hawaii, Chile provide, the Atacama Desert in Chile, provides some of the best viewing in the world. Also the Canary Islands. Antarctica could be thrown in there too, but Antarctica has challenges as being one of the coldest places on the Earth, the coldest place on the Earth. Later on, we'll talk about, of course, our atmosphere protects us, but the ideal place to view objects in the sky, of course, would be outer space, because there we don't have to worry about light pollution, we don't have to worry about turbulence. We can magnify objects to the true optical limitations of our instruments, rather than have to worry about magnifying turbulence and some other things. Okay, so that's the first part of this talk. I'm going to end it right there, and I'll start a new video for the next part of this PowerPoint.